Hello, and welcome to this session on accelerating Azure adoption with Puppet. My name is Martez Reed. I'm a principal training solutions engineer at Puppet. I can be found on LinkedIn, Twitter, as well as GitHub. More and more organizations are embarking on cloud journeys or digital transformations or just forays into the cloud, whatever you want to call it, but definitely moving workloads to the cloud. And so what this entails is deploying business applications into a public cloud such as Microsoft Azure. So some of the reasons for this are agility. And so what we mean by agility is often the ability to develop and iterate on ideas to improve the business at a much faster rate. So what this really translates into is the ability to spin up workloads or services in a public cloud and tinker with those and iterate on those and develop something useful to the business, where it's oftentimes a little more difficult in an on-prem environment to spin up resources and tear them down as quickly as you can in the public cloud. Additionally, is scalability. And so the ability to be able to meet customer demand as demand grows for new resources is often just so much faster and easier in the public cloud than it is in an on-prem environment that you have to go through all the processes of procurement cycle for new hardware, racking and stacking that hardware, bringing it online, integrating with the various systems to make that accessible. It's just a lot that goes into that in an on-prem environment. Additionally, there's the aspect of, as it relates to in the public cloud, being able to scale in those resources when there's not that need for it, which just simply isn't really possible in an on-prem environment, because once you've invested in those resources, that hardware, you can't just give it right back and not have to pay anything, or in essence, get that capital right back. And then additionally, there's managed offerings. And so this would be things like managed databases, to where the cloud provider manages most of the administration and management of the database. Uh, and you're left to really just handle the interaction of your application with the database, perform things like just simply scheduling the backups and snapshots at a click of a button, as opposed to all of the work required to actually manage a full database. So the first thing when we start to talk about cloud migrations or cloud adoptions, after figuring out which cloud, in this case would be Azure, as well as going through the initial setup of accounts and things like that, you start to get to the point where you're having to move workloads. And so in this case, it's moving applications from an on-prem data center, oftentimes to Azure. And so with public clouds, you do have a lot of different capabilities and seemingly unlimited number of services as more services are continually released from these public cloud providers. And so there's the potential to maybe there's a monolithic application on-prem, and maybe ultimately it morphs into something else when it gets to the cloud, some semblance of virtual machines, some semblance of maybe managed service, containers, serverless. There's tons and tons of options. So let's talk about some of those options and where Puppet plays to help the acceleration of that. So one of the common methods of moving workloads is what's known as lift and shift. So this is simply moving an application from an on-prem data center to the public cloud without changing the application architecture. And so, as I said, this is one of the easiest, just simply because you're not having to worry about getting developers to rewrite code or rewrite interfaces or talk to different databases, things like that. It's literally take what we've got, move it to the cloud, and get it to work. So there's two common methods to actually accomplish this from a technical perspective. First one being VM migration. And so this would be something like literally migrating a virtual machine from a vSphere environment and moving it into Azure. Sort of hence the lift and shift. Literally, I'm lifting it out of my VMware environment and moving it, shifting it onto Azure. This is one way. Definitely accomplishes the goal and gets to the point. But one of the things it doesn't do oftentimes is sometimes there's technical debt on those virtual machines that's been accompanied of, let's say, years and years of upgrades to the application, operating system patches, tunes, and tweaks of the operating system from various individuals. And sometimes you don't want to carry that much technical debt into the net new environment, as well as that management paradigm. And so a lot of organizations, as part of their cloud migration, have started to really think about their automation strategy if they haven't already had one. And so for some organizations, if they haven't been leveraging automation to deploy their virtual machines and applications, then this is the perfect time where they start to look at that. And so some things that are commonly involved with this would be infrastructure as code to codify the declaration of the resource. So in this case, it would be like an Azure virtual machine. In addition to configuration management tool like Puppet to install the application, configure baselines of security, install the security agents, install the logging agents, all the various things that go into a virtual machine baseline. And so in that case, we'd be technically redeploying the application onto a net new virtual machine in Azure. And so one of the first things, obviously, we need to accomplish, those that are familiar with Puppet, is installing the Puppet agent. And so in this case, we're going to talk about the context of Puppet Enterprise. And so one of the big advantages and abilities that we have with Puppet Enterprise is the ability to easily integrate the installation of Puppet Enterprise agents with infrastructure as code tools like HashiCorp Terraform, as well as Azure ARM templates. And so this is actually facilitated through the Microsoft Azure virtual machine extensions. So how this works is that you would provision the resource with Terraform and then leverage the integration between Terraform and Azure, in this case, leveraging the custom script extensions to interface with Puppet Enterprise. So what would happen is Terraform would stand up the machine. It would then run the command that you specify via the custom script extension. And in this case, that would be the one-liner that's commonly associated with Puppet Enterprise and made available readily in Puppet Enterprise. And then at that point, the virtual machine reaches out to Puppet Enterprise to install the Puppet agent utilizing the information provided. And so there's various options that can be leveraged as part of this. So here's an example of the Terraform configuration, and we'll walk through some of this, primarily focused on the section that talks about the command to execute. And so those that are familiar with it know that this is the sort of the one-liner installation for Linux of Puppet Enterprise agent. And so most of the things are pretty straightforward. Things that we do integrate in this particular example is a challenge password. So in this case, integrating with auto signing, leveraging a challenge password. It can be various other methods. What we attempt to accomplish here is an end-to-end provisioning process that does not get stalled at a certificate signing. So we would want Terraform to stand up the resource and go all the way through the end-to-end provisioning process. And so in this particular example, we're also including an extension request of the pp_ role. So in this case, we're providing a web role to this particular instance. So this is the integration in Terraform for the virtual machine extension. Very similar construct in ARM templates, but what we're doing is we're leveraging Azure capabilities coupled with Puppet Enterprise's one-line installation or one-liner to actually accomplish the installation of the Puppet Enterprise agent, as well as help with the classification of the node, leveraging things like roles. And so another interesting integration that we have available for that post-provisioning piece of an integration with something like a HashiCorp Terraform for infrastructure as code is Puppet Bolt. And so this is particularly important and I think valuable, as HashiCorp has started the process has actually deprecated the third-party provisioners for HashiCorp Terraform. It's always been their recommendation that you leverage provisioners as sort of that last resort. And so in this case, what the integration is with Bolt is that we're we leverage Terraform, resources created in Terraform, and Bolt dynamically discovers those resources by interrogating the Terraform state after the resource has been provisioned. And so it's very much out of band integration that circumvents the common integration with Terraform, which is you use a remote exec or a local exec, depending upon the architecture, to actually accomplish the post provisioning operation of the system configuration. And so, as you can find on HashiCorp's website about the reason why, number one, they're deprecating it, as well as why they've always recommended it as a last resort, is that there's some inherent complexity with that integration method. And so this is a great way to get the sort of the same capabilities that we know and love, but avoid some of that headache. And so this is an example Bolt inventory file that leverages the Terraform remote state. In this case, we're leveraging remote state, remote backend, utilizing an Azure Linux virtual machine. The name of the resource in the Terraform code is front end. But what we're doing, as you can see here, is we're not statically defining IP addresses or FQDNs. What we're doing is basically providing a mapping of the resource and then leveraging, in this case, it's the private IP address of the virtual machine once it's been spun up. And then Bolt will have access to that virtual machine via that private IP address. So what this really does is allow us to, let's say, expand upon even this example where we include multiple nodes to actually handle the advanced orchestration of, let's say, a multi-tier stack without actually having to hard code any of the very specific IP address or connection information as it relates to where Bolt can find the node. To me, this is particularly valuable as I mentioned, helps with that advanced orchestration. So kind of how the integration works is that from a very technical perspective, is that Terraform provisions the virtual machine. So we're in that provisioning process. And in this case, we're leveraging Terraform remote state via Azure Blob storage to store the Terraform file that ultimately Bolt is going to need access to. So the next stage is, what happens is we get past technically that first provisioning process. So that's that provisioning stage. And then we get into post-provisioning. And so what we have here is Bolt then actually calls Terraform itself. And so that's why in the documentation we reference to make sure that Bolt can, the binary for Terraform is in the path and Bolt can call that. And so it calls Terraform. Terraform fetches the remote state in the case of remote state. It also, the Bolt integration also supports local state. But ultimately what it does is it calls Terraform, and then Terraform feeds or spits out the JSON file or the JSON object. And then Bolt parses that Terraform state, knows how to find the virtual machine that was just spun up. So let's say IP address. It knows which IP address is associated with that resource because it interrogated Terraform state. And then you're deploying the system configuration. And so this is easily done leveraging like a CI/CD provisioning pipeline to where you have a first stage that runs Terraform, and then a second stage that calls Bolt. And then in that particular repository, you may have the Terraform and the Bolt code living right next to each other. You can theoretically split it out if it's for mass consumption of the multiple instantiations of the Terraform code. There are various options, and it makes the integration between the two very, very simple. The next thing we'll look at is kind of, okay, we've provisioned the node, we've installed the agent, or we've leveraged Bolt to kind of facilitate some of that post-provisioning process. And so after we've got past that initial post-provisioning, okay, what integrations can we leverage between Puppet and Azure native services? And so that's one of the common things part of cloud adoptions is you're concerned about getting workloads from on-prem environment into the public cloud. But then obviously, as you're playing with the tools and the capabilities of the public cloud, you're trying to figure out what services have now become available to my organization by moving to the public cloud. And so some examples of those potential integrations might be things like Azure Blob storage for object storage, Azure Key Vault for secret storage of passwords and API credentials and all those things. And then additionally to that, being able to leverage Azure Instance Metadata Service. And so that provides the capability of uh, virtual machines to be able to find out information about themselves, and you could potentially add logic to make decisions based upon what the virtual machine knows about itself. So the first one we'll take a look at is that Azure Instance Metadata Integration. So one of the common integrations or methodologies that's leveraged in Puppet environments is being able to leverage facts. So facts are information about the system, things like hardware, things like even custom facts of like, oh, this virtual machine lives in this data center or is in this location or belongs to this particular environment. And so this integration provides the capability to bubble up or expose the information provided to the virtual machine via the Azure Instance Metadata Service as Puppet facts. And so similar to how we do now with things like data centers, we can leverage information in Azure to make some of those decisions about what we assign, what NTP things that we assign, or even the case of potentially even where we have virtual machines go to fetch resources like things in object storage or interface with particularly regional specific services or endpoints in the environment. There is a Forge module available that does provide that capability. And so you do have to leverage the Forge module to bubble up those facts. The next one is Azure Key Vault integration. I think this one is really interesting because as organizations are moving to the public cloud, they're often looking to add the capability of really securing what they're doing from a credential perspective. On-prem, there's that capability. And obviously Puppet and Puppet Enterprise provide the capability via things like HIRA-EYAML. But what this really unlocks is as more and more workloads are moved to the public cloud, let's say an example is a workload is moved from a monolithic app, is broken up into microservices, and is moved to something like AKS, Azure Kubernetes Service. And so that integration might leverage Azure Key Vault for some of its secrets. And so to help with centralizing secrets and providing sort of that single management interface, organizations decided to leverage Azure Key Vault. Great. Puppet supports that capability to be able to interface with Azure Key Vault. And so both the AKS workloads as well as the virtual machine workloads in Azure can utilize that same centralized store, that same process, that same paradigm for management of credentials. And the way this works from a capability perspective is the advantage public clouds typically have with native service integrations is the ability to control identity of things like virtual machines in that sort of end-to-end process. And so the way the interaction can be done is that virtual machines can be granted access to the Azure Key Vault via the identity of the virtual machine, which is facilitated via the Azure Instance Metadata Service. And so there's a Forge module that provides the capability to do this. And so what happens is Puppet, during a Puppet run, it hits the Azure Instance Metadata Service requesting a token. That gets proxied through to Azure AD. And then ultimately you get the security information back to actually forward on, in essence, the request of a secret to Azure Key Vault. One of the big advantages of Puppet 6 that helps make this really, really amazing, I think in my opinion, is deferred functions, which as its name implies, defers the execution of the function. In this case, the actual interfacing with Azure Instance Metadata Service and ultimate retrieving of the secret until the agent side of the execution. So for those that are less familiar with Puppet, typically what happens is the agent sends information about itself, facts, to the server, and then the server ultimately compiles the catalog of information of resources that should be applied to the node, um, with the inclusion of based upon whether the complex logic or not as complex logic utilized in the factor integration, and then passes that compiled catalog to the agent node. And so before deferred functions, that function would run on the master. So the master would essentially be that proxy. It would hit Azure Key Vault to retrieve that secret, and ultimately it would pass the secret or sensitive data to the agent. In the case of deferred functions, which we can leverage for leveraging Puppet 6, is that gets pushed to the agent side. So the agent can now directly reach out to Azure Key Vault itself and retrieve the secret. So the next piece is the Azure Blob storage integration. There is not a Forge module available for this that I'm aware of, but similar to the previous integration, it is simply the creation of a function to interface with Blob storage. But I think where this is particularly important and relevant is the ability to store large files or potentially sensitive objects in Azure Blob storage, and then have virtual machines grab those files and that information. An example I can see this being used is it's large installation files that are part of Puppet agent deployments. So I need to install an application, store that binary or that file in Azure Blob storage, and leverage that. So the next thing we'll look at is, as companies are going through that cloud adoption, they're often looking to shift paradigms of how they deploy applications, how they leverage the capabilities that are unlocked in the public cloud that they didn't have in the on-prem environment. So immutable infrastructure is one of those common ones that's really associated with public cloud. It's possible in an on-prem environment, but just a little, quite a bit more challenging in an on-prem environment. So what do I mean by immutable infrastructure? So immutable infrastructure is a management paradigm that focuses on recreating virtual machine to push new configuration or resolve an issue. And so this is ideal for stateless applications or applications that offload their state to a third party, or an example might be an Azure Blob storage bucket for some data that it needs to write. This paradigm is typically referred to as cattle versus pets. And so when I need to deploy a new version of an application, instead of doing an in-place upgrade of the application, I build a new template with the new version baked in, and then I roll through old instances, replacing them with the new instance that includes the new version of the application. This is commonly leveraged in the case of Azure with Azure scale sets to provide scalability, especially with like a web tier. The ability to be able to scale out and scale in based upon demand is particularly important. And so one of the other things that we really need to look at oftentimes with immutable infrastructure is baking in the software and the configuration to reduce the time it takes for a virtual machine to become ready. And so if it's sitting behind a load balancer, we would like, as demand hits the environment, to spin up more instances and have those be ready to service requests as quickly as possible. And so that's why we're baking in the software and the configuration and trying to make sure once the node comes online, it's ready to go. And so one way we typically start to create templates now is leveraging HashiCorp Packer to codify the virtual machine templates. Multi-cloud support supports Azure, AWS, GCP, pretty much any public cloud, and even some on-prem cloud, private cloud type environments. Very large community and numerous code examples available of things. One particularly interesting thing is integrating HashiCorp Packer with Puppet Bolt. So oftentimes when you think about things like Puppet Enterprise or just Puppet itself, it's the server and the agent architecture, where I'm expecting a server to be available to hold all the configuration, things like that. In the case of Puppet Bolt, we can leverage a masterless or a serverless paradigm that we, in this example, provision the virtual machine leveraging Packer, and then we can have Packer trigger Puppet bolts and Puppet deploys the system configuration of the node. And then ultimately, once that's done and it's ready to go, Packer closes the virtual machine and converts it to a template and does all those things. So we can leverage our Puppet code and in an immutable infrastructure paradigm and be able to take advantage of a lot of the synergy and the code that we've already written. So how this actually happens is via a Puppet can happen via Puppet Bolt Packer Provisioner. This is actually a custom provisioner actually created by myself. But what it does is it really simplifies the integration between HashiCorp Packer and Puppet Bolts. Supports Windows as well as Linux. And so we can see on the right side of the slide that the provisioner type is Puppet Bolt. And so it has a number of different configuration or settings that can be provided. But it really tries to help simplify the process of how do I execute Bolt on my virtual machine that's being created as part of the process. So the next thing we'll take a look at is operations. And so we've got our workloads moved, we've got the agent installed, we've got leveraging some of the integrations, we're looking at immutable infrastructure. But then there's also the pieces where we start to get to some of those, like those day two operations. Okay, we're in the public cloud, we're there. Now we need to be able to interact with some of the systems and do the ongoing management. And so one of the particularly interesting things about Puppet Bolt is there's another dynamic inventory plugin to leverage Bolt to reach out into your Azure environment and discover resources in the Azure environment in a dynamic fashion. And so it can search by resource groups, tags, location, or a combination of the three. I think this is a really interesting capability that this provides of being able to leverage Bolt and basically just specify, okay, hey, maybe I need to execute a command against every node in a particular resource group, or every machine in my dev environment, or every machine in my production environment. And I'm leveraging a tag to specify those. Or maybe I want to leverage Bolt to just grab some quick piece of information, or lay down a quick file, or whatever it might be. I think this is really powerful to be able to run those ad hoc operations leveraging Puppet Bolt. So here's an example of what that inventory file looks like. Leveraging obviously the Azure credentials. And so it's interfacing with Azure APIs to actually interrogate Azure for those resources. Like, as I mentioned, it can specify location, resource group, tags, combination of those three, and be able to take advantage of the capabilities there. And then the last thing we're going to look at is actually a feature that was released in the latest LTS version of Puppet Enterprise, so in the case of 2019.8, is patching. And so that's always one of the big things in any environment that has some semblance of long-running nodes, is being able to patch those machines and secure them from a vulnerability perspective as it relates to patches. So the capability supports Windows as well as Linux. You can deploy patches based upon node classification, as well as it supports blackout windows. And so what we've really looked at is kind of that, hopefully that end-to-end process of a cloud adoption in all the places where Puppet can fit, and it can play, and it can help speed up the process of, I need to deploy applications, I need to deploy configuration, I need to shift how we're deploying applications now to an immutable paradigm. I need to run ad hoc operations against my Azure environment, or even Azure environment as well as my on-prem environment, or some semblance of both, being able to leverage the tool set of Puppet, and then being able to ensure I'm getting my patches. So thank you for your time in listening to this talk. Any questions can be directed to me via LinkedIn, Twitter, and then the slide deck is included at the link shown at the end. Thank you.